Module 6.10, Decibels and Sound Pressure Levels. Often the way we describe or measure things is by comparison to something else. I'm twice as tall as him. That's half as bright. It's 20 times more expensive. And as we've said before, we perceive exponential stimuli in a linear fashion. And the range of sounds that we generally hear is very large, 2 times 10 to the minus fifth pascals to 20 pascals, which is a range of 1 to 1 million. On top of that, the softest sound we can hear is the sound pressure change of 2 times 10 to the minus fifth pascals, 0.00002 pascals. Considering that 1 pascal is about the pressure that a dollar bill exerts on your arm, 2/100,000th of a pascal is an inconceivably small number. To deal with the large range of sound pressures that we can hear, we use a unit called the decibel. This is named after Alexander Graham Bell, the inventor of the telephone. A bell is the basic unit, and a decibel is 1/10 of a bell. The bell is rarely, if ever, used. Decibels are units that compare something to a reference value. In other words, it is a comparison or a ratio. In our case, we'll use the sound pressure at the threshold of hearing, 2 times 10 to the minus fifth pascals, as our reference. So all other sound pressures are referenced to the softest audible sound. As mentioned before, the way we perceive sensations is related to the exponents or logs of a number rather than the number itself. Decibels use a logarithm to make the ratios relevant to what we perceive. Sound pressure is the physical change in pressure measured in pascals. We will change sound pressure to sound pressure level, or SPL, by taking the log of the ratio of two pressures. But before we do that, let's get a feeling for what relative dB sound pressure levels are and what differences in dBs sound like. Here's a chart showing average SPLs for common sounds. In general, sounds below 40 dB SPL would be considered as soft. Between 40 and 70 dB SPL would be medium. Between 70 and 90 dB loud, and above 90 dB very loud. This chart is very important, as we will now be using SPLs as our regular way of discussing how loud a sound is. So it's important for you to become familiar with the information here. There's a link to this chart in Blackboard so that you can download it and print it. A quick review. The range of sounds that we hear daily range from 45 to 95 dB. Our general hearing range is 0 dB to 120 dB, with sounds below 0 dB being inaudible and sounds above 120 dB painful to listen to. Another important thing to understand is what changes in dB sound like. Here are a few tracks from the audio demonstration CD. Listen to this first track. You'll hear bursts of noise that decrease in volume by a set amount. As you listen, decide if the differences between each successive sound are very noticeable, noticeable, barely noticeable, or not noticeable at all. The track will play twice. Now listen to the next track and decide if the differences between each successive sound are very noticeable, noticeable, barely noticeable, or not noticeable. The track will play 2 times. Now listen to the last track and decide if the differences between each successive sound are very noticeable, noticeable, barely noticeable, or not noticeable. the track will play 2 times. On the first track, each noise burst was 6 dB less than the one preceding it. You should have heard a very noticeable difference from one burst to the next. On the next track, the noise bursts decreased by 3 dB each time. You should have been able to tell that there was a difference, but not a lot. On the final track, the noise bursts decreased by 1 dB each time. Here, it should have been difficult to hear a difference from one sound to the next. 1 dB is generally agreed to be the just noticeable difference, or J&D, for changes in SPL. It is very hard, if not impossible, for most people to hear differences of SPL of less than a dB. So, future sound engineering majors, don't spend a lot of time tweaking things by a fraction of a dB. It is unlikely that anyone will notice the difference. 3 dB is a good starting point for tweaking. So a quick review. 1 dB is the smallest change in SPL that humans can hear. 3 dB is a noticeable difference. 6 dB is a very noticeable difference. Now that you have an idea what a dB change sounds like and how loud a 70 dB SPL sound would be, let's dive back into some math and learn how to calculate dBs.